Hello, my name is Michael West, and I'm the CEO of AgeX Therapeutics and co-CEO of Biotime. In this video, I'll discuss an emerging technology called induced tissue regeneration, or ITR. In doing so, I'll be making certain forward-looking statements that have associated risks and uncertainties. I refer you to Biotime's filings with the Securities and Exchange Commission for more detailed information about the company. The largest component of the nearly $3 trillion we spend annually in the United States for healthcare relates to chronic disease, and it's easy to see why. In acute disease, such as a sore throat, that can easily be treated with antibiotics in a few days, it has very small costs compared to, say, stroke or Alzheimer's disease that can greatly impact the quality of life both for the patient as well as the family and require years, not days, of continuous care. And the greatest problem in chronic disease is that associated with aging. We're on the verge of experiencing a tidal wave of chronic degenerative diseases, problems like Parkinson's disease, osteoarthritis, heart, kidney, and liver failure, as well as many other similar long-term degenerative conditions expected to cost the United States over $1 trillion annually in coming decades. Unlike adult humans, some animals escape these problems through a remarkable capacity to simply regrow or regenerate tissues lost by trauma or degenerative disease. Even more amazing is the observation that some animals, like these flatworms called planaria, if cut in half, they simply completely regenerate. The tail regrows a head, and the head regrows its tail. Because these animals have full regenerative potential, and in addition have the ability to regenerate forever through the expression of the immortalizing gene called telomerase, they actually don't age. They can die, of course, if, for instance, they're deprived of food, but they have the potential of regenerating damaged tissues in their bodies endlessly. What if such ability could be unlocked in humans? We've heard a lot about breakthroughs in the understanding of the biology of aging, but what can we realistically expect to see coming into the clinic with your local doctor or on the shelves at the drugstore, say in the next 10 years? A lot of the sciences that are being implemented today and in the drugstore today are dietary supplements, things like vitamins, things that can improve the quality of life for you and me. But most of these dietary supplements just fine-tune the biology of aging. They don't reset the clock of aging itself in the cells in our body. They don't fundamentally change the biology of aging itself. In the next 10 years, there may begin to be the implementation of some basic science that was discovered in the mid-1990s by some of the scientists working with me and others in the biology of aging. And this is based on what we call regenerative medicine. Very simply put, we can keep an old car on the road by continually replacing old worn-out parts. So you might see a Model T running down the road today. Not exactly the same car that existed many decades earlier. The tires have been replaced. Maybe cracked the windshield, needed a new windshield. In the same way, in the mid-1990s, cells were discovered at the root of the tree of human life itself that can branch out and to make all the cells of the human body. We call these stem cells. These cells were very different than any cell ever previously isolated, and they can make all the cells of the human body. They're also extremely young. In fact, they're immortal. So sort of like a new part that you would buy in a parts supply store for a car. Those cells are being applied even today in the clinic in clinical trials for age-related diseases. One of these is for age-related macular degeneration, a change that can cause blindness in aging people. This has the potential to be applied in human medicine within the next 10 years. We believe that the ability to regenerate is a natural process that allows the body to form at the very beginnings of life. In primitive animals, this ability is maintained throughout their life, and so some of these animals simply don't age. Higher up the evolutionary ladder, however, species only show that trait when it is necessary for the body to form, and then at what is called the embryonic fetal transition, or the Weissman barrier, it is turned off. In the paper, we show an example of one such gene called COX7A1. It's not expressed in the immortal germline or when the body is first forming, but begins to be turned on after the body is formed, playing a role, we believe, in blocking the potential to regenerate. In 2010, Biotime announced that it was possible to reverse the aging of human cells using a technology known as transcriptional reprogramming. In that work, we showed that it was possible to revert aged human cells back to the very beginnings of life, resetting the telomere clock of aging and allowing the cells to again have the potential to make cells of any kind. In the current study, we asked whether transcriptional reprogramming could also induce regenerative potential. Here, for instance, we can see how this gene is reset back to an embryonic regenerative state in 3 separate samples of skin cells taken from adult males in their 60s. Another very important discovery that we report in this paper is that cancer cells have nearly universally reverted back to an embryonic profile. It's very rare to find a change in gene expression common to nearly every type of cancer. I had the privilege of being part of a study in the mid-1990s that reported that the expression of the telomerase gene was abnormal in approximately 90% of all human cancers. In a similar way, we report in this paper that the COX7A1 gene has reverted to an embryonic state in a vast majority of carcinomas, adenocarcinomas, and sarcomas. So how can we use these discoveries to make important new therapeutics? Is it possible to reverse the aging of human cells and in doing so, restore regenerative potential in aged human cells? We believe that it's a much simpler task to do this than it was to revert cells all the way back to the beginning of life. Since the recent financing of AgeX, we've begun to screen small molecules in a search for formulations for a drug we call ITR. We have screened over 200 such candidate formulations and believe that we have found compounds that have preliminary efficacy in the laboratory. Importantly, one such compound is already known in medicine for the treatment of a completely unrelated problem. It is known to have a great safety profile, and so we're planning on developing that compound as a first-generation product. And we call that development stage product Renalon. You've probably seen, and maybe in the main session or elsewhere, this horrendous demographic we're experiencing in the United States and around the world, the age wave. The point I wanted to make was it carries with it the problem of chronic degenerative diseases. That accounts for about 80% of the healthcare costs in the US, and the reason is about 80% of the elderly have a chronic degenerative disease because cells in our body can't repair the damage, and so we carry it for the rest of our life. What am I thinking of? Parkinson's, heart failure, the pain of arthritis or degenerative disease in the spine. You know, the body can't repair that stuff. Unfortunately, 68% of the aging population has 2 or more of these simultaneous. So the work I just described that was done in the past 20 years or so is really aimed at inventing an entirely new platform targeted for the most urgent needs of an aging population. We do it by making young cells of all kinds and a matrix to allow the regeneration of that tissue, be it the heart or the brain or whatever, and that's our prescription for regenerative medicine for an aging population. We have a lot of patents, having invented most of the technologies in the field. If you dig deep on our company, you'll see that PureStem, a way to manufacture pure cells, just the cells you need for a particular disease like heart failure or whatever it is, on an industrial scale is a core technology of the company. And then what we call Universite, it's a way of engineering cells so that your body doesn't reject them, so we can have an off-the-shelf product for all people. Really a revolutionary idea, a technology we own at AgeX.